Guys, thank you very much for inviting me to talk today. Actually, I'm not always that keen on that inspector thing. If I'm honest with you, I think it sometimes sort of frightens teachers a little bit. And actually, I'm a teacher. I still teach for 2 days a week. Yeah, I have no idea what they're doing this week. We'll find out whether anything I left actually got done. You know what I'm saying? Okay. But I do also work for 2 days for Hampshire, which is a region of the UK. Here we go, there's Hampshire. Okay, we have lots and lots of primary schools, lots of secondary schools, some of them in cities, some of them outside, real mixed, totally mixed, different types of schools, different needs. And it's really nice to work with lots and lots of teachers as well over quite a few years. When I spoke at the last conference on Friday, I sort of described my journey through sort of total and abject failure most of the time, falling into loads of holes, doing all the wrong things half of the time, and some of the sort of little nuggets and things that, you know, we sort of learnt along the way. But I didn't really want to repeat the same talk. Who was here on Friday? Yeah, so I didn't want to, and actually we were talking earlier and you said, oh, I'm glad you're here. Are you going to do exactly the same talk? And I was like, no. And he was like, phew, you know, because you know, it's nice to sort of do some other stuff and sort of go on. So what I want to do is spend a little bit of time just talking through 2 key areas that have made a really big difference, which I did mention on Friday. And then I'm going to sort of take you through some of the stuff that we do from K to 6. Now, I know a lot of you guys are 7, 8, 9, 10, 11, 12, etc., etc., etc. But what's quite interesting, sorry?
I'm K6.
Hey! Oh, brilliant, thank you. Anybody else K to 6 or K to 5? Oh, brilliant. Oh, great, thank you guys. Oh, you've cheered me up already. Okay, thank you. So, I'm going to go through some of that. And I'm going to really sort of talk about a progression of materials. Probably one of the biggest mistakes I made. I'm not going to blame anybody else. I'm going to blame me. Okay. One of my biggest mistakes was jumping in way too deep, really, really too early, and it was a real crash and burn one. You know, so I thought to myself, oh, children should be able to do this. They're 10 and 11-year-olds. You know, and so we gave them really complicated programming projects and they didn't have a clue. They looked at me, I might as well have been talking Spanish or some totally other alien thing to them. They hadn't really, you know, and I sort of realised that you sort of got to go back and start from the beginning with everybody really. That's been a sort of a key sort of learning thing. So, without further ado, let's have a little look. If I'm a little strange tonight, it's only that I still haven't totally worked out the jet lag thing. In fact, I woke up almost every day this week at sort of 4 or 5 o'clock in the morning. And this morning I woke up at 3 o'clock in the morning. So I'm going backwards, you know, I'm sort of working my way back home in a sort of a weird way. So let's start with some ideas that make a difference to teaching. Okay. This has been a really big one for me, okay? Now, we definitely spent time really looking at computational thinking, and I'm a really big one to say that computational thinking without the computation is just thinking. So I'm a big one to say that actually we need to do some stuff and make some stuff, kids enjoy that, but we have to have the thinking as part of it. And I liked all that, and that really did sort of expand our practice, and I shared about that on Friday. But actually, one of the things that we have been using is this. And quite recently, we worked together with Mark Dorling and a few other guys, some guys from the States as well as the UK, on developing a problem-solving rubric. Okay, and that's been really interesting. That was a really interesting sort of hashing for about 40 different drafts of this thing between all sorts of different people, and then they come back and say one thing, and then all that sort of process. And we looked at, well, what does a hibernating student look like in these areas? Now, what I mean by hibernating, you know, maybe they're even slightly actively working against you. They don't want to do that. They don't want to do that good stuff. Okay, and then someone who's just passively starting to get involved and a bit more sort of really, you know, on board, and then, oh, really flying at the end. Those are not the categories, I can't remember what they were, but, you know, they're all there. I would encourage you to have a look at it. It's quite interesting. And please, this is not a totally finished draft. If you have anything you want to put in there, email myself or Mark. Okay, our emails are on the bottom of the document, and add in. So now, I like this, but this is not something I could give to my kids in K-6, you know. They're like, oh, you could possibly work with high school students on some of this. And we had a really nice talk to some of the guys. Where did we go and work with the two guys at the software engineering? At AFSI. Yeah. Academy for Software Engineering. Yeah, so we had a really nice chat with them, and they said they probably would use some of that sort of more directly with students. But hey, that's everybody's, it's about adapting stuff. So what we did is develop this into this. So this is my sort of paraphrase of all of this. And really, it does have a whole load of computational thinking in there as well, but it also recognises some other real important things, such as communication skills. You know, we have all this other stuff, but actually if you can't work with other people, doesn't matter how good you are at doing all the tech and understanding it and programming it and all the rest of it, you're going to struggle to get a job. You know? This has been a massive one, this perseverance thing. You know, if you can't persevere, you will not survive programming. You know, it's all about perseverance. You guys are all nodding at me. You know what I'm saying. Okay. This was a big one for me, the evaluation side of things. I'd done some of that, but I don't think I'd really sort of emphasised that enough. And I loved looking at open-ended. And I have to say, I now look at every single curriculum that comes past my door in light of actually how many of these does it actually develop with my students. Now, don't get me wrong, there's no module of work in existence that does absolutely all of those. But I'm always looking for how many of these over a period of time, okay, will get developed. And actually, personally, I've started to put those projects on a bit more of a back burner that don't develop as much of this. And those projects that I think, that does develop the open-ended. That does challenge them to think about more than one solution to something. I can get a bit of adapting existing ideas to, you know, so that they have agency over it and they can do what they want with it as well. We can make a real point about some of this sort of loop of testing and seeing if it works and then go and retesting and that sort of investigative cycle. Okay, and if stuff sort of handles a lot more of these, I tend to put it as a bit higher on my agenda of things that I think is worth doing. Okay, so that's been a really big one, and I just want to talk for a few little areas for myself that it's made a difference. Okay, oh, actually, before we do that, I didn't show this slide on Friday, but this is just a little bit more of where it links to computational thinking, and also those really important areas that are, you know, just as important as all the other stuff, really.
And we're going to share these slides, right?
Yeah, sure. Yeah. I'll either give them to Meg, or I'll stick them on my website and give you guys a tweet to them. Does that sound all right? Okay. I did get told off actually because this is not particularly very good with the colour phrasing for people who are colourblind. So apologies for that. I will make a new version of that at some point. Okay. I think that's a good point. So this has been quite important, and actually how has it affected my practice? Okay, well, this one was a big one for me, this open-ended problem solver. I noticed in my own practice that actually I often found that it was the quicker finishers. Maybe, I'm not even totally sure they're the more able sometimes. I think sometimes they're just the ones who get something finished a bit quicker. Okay, maybe the others spend a little bit more time thinking it through and getting it done well. So I noticed these kids who finished quickly, okay, they got all the opportunities to do those extension activities, to discover or maybe make a little bit more of what they wanted to do themselves. And I thought to myself, actually, if this is a really important set of thinking skills that I want my children to develop, I've got to give everybody that opportunity. So now I do quite a few projects where we get, say, 4/5 through the project and I cut off everybody. And I say, we're all going to stop there. Right, okay. Now, you tell me what you want to do with this. How would you like to adapt this, change it, take it on, do what, you've done some of my stuff and you've done some of your own stuff as well, depending on the project. But actually, you tell me. So with my younger pupils, my sort of year threes, we might do a post-it note, and even younger than that, they might tell me about it. Oh, I want to do this, Mr. Bagge. Oh, that's cool. Okay. And then we'll give them at least a lesson to do that, because actually that sort of open-ended stuff is really important. Okay. So that's been a big one for me, and how that sort of changed my practice through that sort of attitude thing. Another area that's been quite important has been the whole evaluation thing. In fact, I saw some really nice evaluation in one of your schools today, so that was really there was a lovely teacher doing some great evaluative work, so really nice to see. Okay, this whole thing of involving pupils in their design evaluation was a big one for us. Now, I don't know, have you ever heard of WAGOL? What does a good one of these look like? So it's been quite interesting asking children, at the point where you get halfway through a project and you're into it, and you've got a bit more understanding about what you're doing, what you're designing, what you're thinking of, just getting them to say what they thought a good one looked like. And that's really interesting. So then they are actually much higher level critics of what they think is good than I am half the time. So they will come up with loads, and just recording those. Okay, I often go around my classroom with my phone and just do a quick sound record. Okay, and then turn some of that information into a peer evaluation sheet. Okay, maybe sometimes I add a few bits on there, it just depends, but actually 9 times out of 10 they come up with all the good stuff. I don't really need to do that. Then it's their evaluation. It's not mine, so they have a lot more ownership of it. You're the one who thought the evaluation. No, I didn't. I'm not imposing something on you. Okay, so that's been fun as well. Well, that was good. Really went well, but we really had to have this right of reply. I found a lot of students were very sort of loath to say anything really about their pupils, or they said too much. They just went for, they were hypercritical. So we brought in this right to reply, where you could, if somebody left a comment on what you said, and they had to put their name on it as well, because that's important, ownership of your comments, no anonymous commenting on other people's stuff, none of that works. I'm sure your teachers, you're all nodding at me, okay? This whole I agree with your point, I'll try to change it by. And obviously if you've got 2 or 3 people giving peer feedback and all 3 of them say the same thing, then that adds weight to it, doesn't it? Okay, but this, I don't agree with your point, because occasionally they didn't get it, and the original person doing something did, and that's cool. And then I get in and mediate that, and that's fine. That's how it should be. So that's been a big thing that sort of changed my practice. Maybe you guys were doing good stuff in that area already, but that's been a real interesting thing.
A good scratch fortune teller should have sort of interesting questions and something that
to some of my kids
gets you to think and gets you to answer your mind rather than going yes, no.
Okay, just some of the kids talking through and giving some of that Bagge stuff. Okay, this has been another interesting, and this is a project that I tend to do with my 7 and 8 year olds. It's a really introductory scratch project. It's around making a magic carpet. Okay, and so we do a little bit of decomposition. We have a good look at the actual program working. Okay, and we don't look at any code. We just have a look at the program working, and then we say, right, circle all the stuff that you want to make it go and do. So they have to go and choose the bits. If they're struggling to read that, we'll read them out and they can circle the one. They've decomposed the project, they've thought it through. Then we might say, well, okay, put a 1, 2 or 3 by the job you think needs to be done first. You're going to go and build this in a bit. Okay, this is really interesting. Okay, and we're starting to discover or concentrate on the most important part of a problem. What do they think is important? And it's really interesting the things that kids say. So a common one with this is, oh, I'm going to make the instructions first. Okay, so all right, I like that idea. But if you only get to make the instructions, would you be happy with that? No. You know, I want to make the carpet move and fly about and steer. Okay, so, you know, maybe that's not the most important. You know, you'll have to decide. Okay, so that's been quite interesting, sort of just focusing on that. And that came about because of this focus on finding the most important aspect. I would also say that that's sort of the early stages of abstraction. It's not abstraction in any way near. You know, it's a lot more complex than that. But it's like a precursor to it. It's like the sort of a proto-abstraction if I wanted to start and think of something. Okay. This is the other big idea that's been massive. Okay, this is the thing that I've seen make the most difference, and this is about developing resilient learners. And when I first started teaching this, all right, my kids, I ran around like a crazy person, fixing all of my students' stuff all over the place, okay? I really it drove me around the bend. I'd actually given up my job and gone to teach in 5 different schools. And I dropped salary for that, and it was a big career choice, and there was no national curriculum for computing, and I just and at this point I thought I have totally and utterly failed, gone to the wrong thing totally, okay, because I was just running around doing crazy things really, trying to fix all of their stuff, and I realised that I was just making them more helpless, you know. So I noticed that I had a whole set of pupils in my class who were pretty helpless. Okay, they were the kids who, you know, when you said to them, "Are you stuck?" they put their hand up straight away, you know, or "We've just finished, I've given you a set of instructions, off you go and do some work," and then, "I don't know what to do, Mr. Bagge." All right, like this. And I realised that there was sort of a bit of helplessness that was going on here. And I realised that actually part of it was me. I was just making them more helpless by doing their stuff for them. Okay, so I would describe helplessness. Helplessness is not being stuck. You know, stuck's good. In fact, if there's no stuckness in our learning, then actually I don't think there's any real learning. You know, and yes, there's all that zone of proximal development. You know, we want them to be stuck inside something they can actually reach within a reasonable, you know. I often say, look, you know, if you were trying to get your kids to redesign Microsoft Word at that point, you know, and they're 7, then probably that's a bit outside their zone of proximal development, you know. It took 100 programmers X amount of years to produce the same version of Microsoft Word in a slightly different way. Right, let's not go there. I apologise for that. So I would say helplessness is stuck and no attempt to find a solution yourself. Okay. And we noticed 2 types of helplessness in classes. There was the sweet type of helplessness, and this was really sort of, well, I'm just going to put my hand up and hang about here because while I've got my hand up, I don't have to do anything. So I can look out the window, and then I will pretend that I have no idea about any of this as well, and you will just work your way through a whole set of stuff and you'll do it for me. Okay, so it was that sort of sweet helplessness. Or even more so, instead of just doing it to me, they would do it to the person next to them. They get the kid next to them to solve the stuff. All right, and that's just as bad. All right, and in fact, we have a whole culture in the UK around what we call digital leaders. And those are people in the class who are supposed to be sort of leading in the right way and helping their peers. And we've had to totally train them to do stuff differently. Because of course they ran around the classroom doing stuff for everybody thinking they were helping. And of course they're not helping, they're just making even more people helpless. Okay, and plus the fact, while they're running around the classroom doing stuff, they're not doing any learning, are they really? And that's not particularly helpful for them. Hey, I tell you one of the things that we do, and that's we do a frequently asked questions, and this has been quite fun. So I'll just share this with you. Okay, so can I write on the board with that? Is that a great erase bold? Is that going to be okay on?
Yes.
Okay, cool.
Yeah.
So I only asking because I did this once before and it was a Sharpie. Let's not go there. Okay. So we would have a frequently asked questions board, and we would think of any questions that we think might come up during the lesson. Okay, beforehand, and then we'd ask at the beginning of the lesson: is any kids who know how to give someone a hint? You know, not a full solution with these things, and they're much more procedural things. If they're about code, I don't put them up there because I want them to puzzle that. Okay. Then what we do is we write those up. Kid will come and put their name underneath, And then we'll say, right, you are allowed to go and show somebody that thing. But as soon as they've done it, the next person, so say I'm the person and I come and work with you, sir, and why didn't you start there? And, there's a good thing to do, but I'm not going to do it all for you. Okay, and then as soon as I've done that, I go and rub my name off and I put your name up there. So now you've got to be the next person to go and do it. So I've not got that same person running around doing all the work for the kids. And I'll tell you something, you would have to really listen to what's going on, because you've got to go and do it for the next person, rather than that sort of surface listen. We don't really bother to listen to somebody because actually you know that you can get them to do it again and show them again. Okay, that's sort of helpless. Do you know, I'll tell you what I also noticed with all this, how many teachers did it as well. It's been quite interesting talking to teachers and saying, well, okay, do we do that with our colleagues? Oh, I need some help with that, filling in that assessment set of forms. Phil, you showed me last year. Well, I showed you last year then, didn't I? Did you write any notes? So actually, our colleagues can be as helpless as the kids sometimes. So we noticed this sweet helplessness. We also noticed some quite aggressive helplessness, which was things like, and I remember really sort of stopping the sweet helplessness in the class. Okay, so I've got no kids who are being like that, and they are not solving stuff for the kids. The funny thing is, children love this because it's fair. When they really think about what they're doing when they solve something else, you're giving all of your stuff that you bothered and you fought through and and you did all of that good mental stuff, and you're just giving it away for free to someone else. And actually, kids don't like stuff like that, really. It's quite unfair. Okay, they like a bit of fairness. Ultimately, we'll all be judged on what we produce and what we think. Why should I give away all that stuff? Okay, so the hint culture, I think children do like. They do like giving a bit of help, that's important. But the hint culture rather than solutions is good. So we had a kid who was really aggressive with me. Came in, I don't know why we're doing all this computing. What's the problem with the point of all this rubbish then? Okay. And that was her being, giving me some sort of aggressive helplessness. Okay. So, all very well talking about this, what are the sort of solutions that have really worked for us? Okay, these are my 3 commandments of computational doing. So every programmer makes mistakes. Okay, mistakes and debugging are a totally normal part. A lot of kids are totally risk averse because they don't believe that this is a normal part. And it's not a normal part of all their other education because people tell them off when they make mistakes, or they tut on it, etc., etc. But actually, it's totally normal part in programming. We tell teachers who are doing this for the first time, we say go and ask if there's any programmers who are parents in your class. Go and make a 20-second video about debugging and bring it back to show the class. And then, of course, what do they say? They say, oh, the bugs are normal. I have so many bugs this week. I don't get hassled with it. It's normal. And then parents, and then the kids start to realise, hang on, this bug thing, it's not I make bugs because I'm learning programming. It's we make bugs because we are doing programming at whatever level. Okay, and then different mindset, really. And this is a big one. It's not the teacher's job to debug or fix your pupil code. That's such an important thing, really. That I had to learn that the hard way myself. And in Hampshire and all the other places I go and visit, that's a big one for helping stopping teachers. And certainly when I inspect, I see lots and lots of teachers jumping in and fixing things for children. Okay, and actually all they're doing really is sort of developing that sort of helplessness, sort of carrying it on, really. Okay, so here's a few things of how we've sort of been working to get children out of this. Okay, hints not solutions, I think we sort of mentioned that. That's my sort of ultimate mantra. Okay, my kids get fed up with listening to me say that, but actually it's important. And actually, it means I really enjoy teaching now because I wander around and I don't have to do most of the work. The kids do it. Yeah. I really do like it. It's taken me months and in some cases years, but it really works. Do you know what? If there's one thing, I love computing science, I love all of that, but do you know, if there's one thing I think I've probably given children more than anything, it's the ability to stick at something. Okay, so I know kids who gave up in the first 3 seconds, who now will last for 25, 30 minutes of puzzling, trying stuff, doing different strategies, thinking it through, getting hints from somebody but not solutions. And that's just wonderful, because actually, I mean, I'm a primary school teacher, K1 to 6, and actually, I mean, I love the computer science, and some of them are going to get into that. But actually, if they become resilient learners, then they'll do well in anything. I really believe that. So this is important. Process is more important than outcome. You know, the process of solving stuff. So often we'd have teachers who wanted to always finish all of the projects. So what would happen is you got near to the end of the project and the teacher would start getting a bit twitchy about sort of solving that thing. I've got to get it done because we've got to get the kids through these projects. And so what they would do is they would start going and doing those things. Or can you just help so-and-so over here? You know, or I just jump in and do a little bit here. Of course, what they're doing really is perpetuating in the kid's brain that actually that's the solution. If I just leave it till the end, my teacher will send someone to sort it out for me. Okay, that's cool. So I don't need to worry about it. Okay. Establishing a positive attitude towards problem solving. Using bug and debugging language. Children have loads of baggage around all the other failure words. But they don't about bug and debugging because, of course, it's new. So you can do it in a different way. We have debugging stickers. We give children, if a child solves something and they solved it with only a hint, okay, then they can come and have a debugging sticker and we'll stick it on the Debugging Hall of Fame. Okay, now, my younger pupils, they just do that stuff just to get stickers. They even make bugs early on. They do, I know they do. But to be honest, they get bored of that because, you know, making bugs is boring on purpose. Okay, but what it does do is it reinforces that that's more important. I praise children who debug much more than I praise children who just get stuff right first time. Okay, I'll tell you what we've been doing with older children as well, which you might be interested in. We've been putting columns for different types of bugs. So if it's a syntax bug or if it's a bug, a logical bug, and actually columnising those and then saying, right, okay, so when you've actually got your debugging sticker, go and snap it into the right column as well. And it's been quite interesting then getting them to feedback about, oh yeah, that's quite interesting. You know, how many bugs have we sort of come up in this lesson? What type of bugs are they? You know, so that's been quite interesting. I'd quite like to work a way of doing that automatically. That would automate all of that. I think there'd be quite interesting evidence around some of that. And I know some systems do that, but just not quite the ones I use. So there we go. Challenging the attitude's been really big as well. Okay, actually just saying to children. Now, I'm not saying challenging them in front of everybody else, but just going down quiet and saying, you know, are you trying to get me to do your work for you? And just walking away before they get cross. Yeah, I'm a coward at heart. You know, and to be honest, I don't want to get into a great argument. I want them to think about it. Right. So if I say it and quietly, you know, without all their friends hearing, and I just leave it with them, because that's actually what they're doing. They are trying to get me to do their work for them. And actually, they're never going to survive out in the big wide world, are they? If they expect the person next to them to do their work for them. You know, that only lasts for so long. This is a big one. Moving away from language that personifies digital machines. So my computer hates me. It always does stuff for you, Mr. Bagge. Hates me. Do you know, I see, this is a big one for teachers as well. Okay, so a lot of teachers do this type of stuff. Now, what they're really doing is saying there's something nasty, capricious, horrible about the computer, and that's why they can't fix the problem. Now, the chances are, okay, that actually they can't fix the problem either because it's too big a problem for them. That's cool. You know, there is some stuff that I'm nowhere near fixing ever. You know, so, you know, we just say, do we know someone who does know how to do that? Okay, so we're just positive about it. Problem is, it gives children an excuse for why they can't fix stuff. I can't fix it because the computer hates me. Well, it doesn't hate you. It's an inanimate object that somebody's given a load of instructions to. Okay, it feels like that, but that's not what's happening. And I also will talk about this children do what we do and not what we say stuff, because I think that's really important. So I have a lot, especially in K-16 when we're teaching loads of other stuff, teachers often think, well actually the computing only really happens when I'm doing computer lessons, or I've got out the tech, or I've got the iPads out, or the Chromebooks or whatever. And so they'll be quite negative about the technology in other lessons. They'll say stuff like this and then wonder why the kids take no notice in a computing lesson. So what we just have to say gently, because it is a gentle thing, because is if you do those, if you say those sort of things in a history lesson or a maths lesson or something, then your kids they don't have a compartment. Oh, I'm going to switch on my computing brain now. Bing. They'll pick that up earlier, and that's what they'll do later. So that's been a big one for us. Now, just want to talk about a bit of progression and a bit of and talk you through some things that we do in the UK. Not every school does this, but there's lots and lots of schools which do. So it's nice to sort of just show you some of the stuff that we're doing. Nearly all of the examples for here are on my website. I'm stupid probably, because I give away almost everything for free. So if you like anything, download it, use it. I'm cool. If you want to adapt it for your school, I'm cool with that as well. And if you want to publish an adaptation of it, just say where you originally got the idea from. I'm really cool about it. I'm a big one I love it when teachers contact me and say, in fact I had a lady this week, and she said, oh, I've used some of your Scratch stuff, but we've adapted it a bit. And she said it almost apologetic to me. Can I put that out there? And I was like, brilliant. Because that's real teacher agency. I've tried something, I've done it a bit, and then I've adapted and done something else with it. That's brilliant. You've made me the happiest person going. It's actually worth putting some of that stuff out there. So I really don't mind all of that. This has been we did this actually with the teachers from Roosevelt Island School. So this is creating a robot world. Okay, now we use little B-bots, which are little programmable things. Those are great. I've seen a lot of you guys over here use little robot mice you sometimes see. Any others that people... Bluebot, yeah, Bluebot's even nicer if you can afford. A lot of our schools had the older yellow ones before. But yeah, Bluebot's it. Yeah, Bebot, Bluebot, the robot mouse, are fantastic. So one of the things that works really well is we get the children to design their own world around this. Okay, so we always aim it around a theme that fits for the teacher. So, it's not for me to tell teachers what to theme it around. So when we were talking to the Roosevelt Island guys this week, they were saying, we're doing a local history project. So we'll have the tramway, because that's really key for us and we know where that is. We'll have the bridge, and so they were putting local landmarks into the thing. And then they were drawing some roads to join them up and colouring it all in and making it look really cool. Okay, what's nice is they all design different maps out of this, which is really useful for us in a bit. So then what we will do, and this is using the B-bots, is we'll get children to put down a set of instructions. Okay, often just to go from A to B, telling simple stories about hey, I'm going from the tramway to the Brooklyn Island Bridge. Okay, and we get loads. One child puts the instructions down. Another child is only allowed to punch in exactly what was in that algorithm in the first place. And we're really strict on that. That's probably the most strict thing. If children press the go button and they haven't put a go card, I'm like, oh, nope, you can't press that button. Or if they press the clear button beforehand, and they haven't put the card down. So we're really sort of chasing them about that stuff. And then we'll get a child to trace this. Notice a few programming examples here. So trace those instructions bit by bit by bit as they go down. All right. What's quite nice is we don't just stop there. All that stuff I think I've seen already. But what we do is things like we try and develop a bit of algorithmic evaluation as well. So we might put some counters down here, different places, and we might give the children a set amount of cards. You see those cards, and we might say, well, okay, how many counters can you pick up with the cards? So then they'll try and puzzle, oh, this is one algorithm. Oh, but could I do it like that? What's quite nice sometimes is to say, well, actually, we're going to get the next table to come down and see if they can beat your one later. So, you know, it's a bit of competition sometimes. I think that's quite good. So that's a really nice, and then often they can't do it. I'm nasty like that. I always give them too many counters, and then we'll say, well, can you pick B-bot up and pop? If you could start B-bot anywhere you liked, could you pick up more? Or what's the least amount of these? And you can see how you can adapt it. And what's nice, we do this sort of stuff and teachers start sort of getting it. What's quite nice is to draw some different pathways as well. So we draw 2 different routes and say to the children, what's the best route? Now I deliberately keep that best really loose because I want them to come up with what they think is best. Oh, Mr. Bagge, visiting the most things is best. Well, you know, if you're going for a Sunday drive, do you guys do Sunday driving here? Or probably not in New York. Sunday walking is probably better for you. You know, so they'll say things like that. And we say, great, okay, so we're going to investigate that. And because we've got loads of different maps, because they've drawn their own, if you investigate for one, it's going to be different for that one, isn't it? Okay, so they enjoy that. Or that somebody else might say, well, actually, it's the distance. Well, here's some children using 15 strips of card, cut to the same thing to work out the distances from the middle. Nice thing is you can take them off, pop them on the ground. You've got a nice little bar chart, all right, already there. Okay, or we can do time, or we can do the number of instructions, or sometimes children say the least amount of turns. We can almost investigate anything they want. Okay, in that, and they're evaluating different algorithms, trying to find the best one, which is lots of fun. So I love the B-bot work, and the children do too. Here's a nice little unplugged activity. This is the human crane algorithm. Okay, so we've got some cards here and we start off with really simple challenges. We put some pots in front of the children. Can you write an algorithm? When you put an algorithm together, just move that across like that. Okay, and can your friend then test it? Hey, don't do what I did the first time I did it, and the children were facing each other. And of course the cards were all round the wrong way round. But hey, you know, they learn those things. I learned that thing as well. Okay, that's actually my daughter's finger. She was really cross. She went into school and her teacher did the human crane activity, and she said, "Oh, that's my hand." and they said, "No, that's not your hand." And so she came back, "Dad, don't say it's not my hand." I said, "Do you want me to tell the school?" And she was like, "Oh," she said no, and I was so pleased. Because as a teacher, I can't think of anything I'd have to do worse than go in and say something like that, you know, to a busy teacher. So I was really pleased. Anyway, nice little activity, little unplugged thing just to think through. Okay. I have to say, we're big on Scratch Junior. Anybody use Scratch Junior here? Love Scratch Junior. So we do loads of things such as, let's have a look at some of these blocks here. What do they do? Oh, we've got the jump and the move and all the rest of it. Okay, then we will do things like getting the kids to go outside and design a dance using some of those arrows. So that's their algorithm. Maybe doing a circle round it and saying how many times if they want to repeat stuff. So we get them to do a bit of that and then come back and convert that, put all the music in it, all the rest of that stuff. That's loads of fun. I really enjoy doing that. Okay, that's a little example of their algorithm before actually making it into code and adding all the rest. There's an example of one of theirs. Can we make both of them do it at the same time? Of course you can. Go for it. It's loads of fun. Okay. Here's another little example of some stuff we've done with our slightly older children. Okay, and this we actually start by getting loads of chairs. I'll just nick that for a second. Okay, so we start by putting loads of chairs out as a sort of obstacle course, and we think about doing some human robot type stuff, you know, moving and turning to go through that. And then we say, well, we thought that through. Let's see if we can make some sort of program that gets the little scratch cat to move through stuff, and if it hits obstacles, it'll go back to the start. Okay, so we might look at how we can decompose that and build a project, and then they can go and build their own thing in there, which is lots of fun. Okay, some planning for that and a video for that as well. How a supermarket works. What? Well, you know, we've got all this technology around us. In fact, quite nice looking at your new CS framework. Is that the right word for it, CS framework? Bloody hell, I'm getting there. Okay, so here's a little thing we do with the children about how supermarkets work. So we actually role play a lot of this stuff. We role play kids being the scanners. We role play kids being the data. So we will have a child, okay, and we were, say it's a supermarket, we have like tins of beans cards. So we'll say, right, okay, there's 9 tins of beans, here's the cards, that's the database. We can call it database, call it the list, it's in the computer. Here's 9 tins of beans in our shop. Let's go play shops. When someone buys a tin of beans, a kid who's pretending to be the information rushes down and says, hey, take one of the tins of beans off, okay? And we take one of the tins of beans off, and then we talk about, well, actually, when it runs out, what does it do? Well, it sends a message to the warehouse. We go and collect all the tins of beans, pretend they're new tins of beans, restock the shop, okay, and we're back in there. And it's a great opportunity to talk about some of that tech stuff that is out there that children use all of the time through a sort of role play context. One of the things we did when we were talking about to parents recently is encouraging parents to be digitally curious. You don't have to know all the answers to understand how something works. You just have to ask some of the questions. I wonder how that tramway thing works. You know? You posit a few questions with your children. I wonder, why, you know, you go through this tramway almost every day. Have you ever asked the guy or the woman who actually uses it what those weird buttons do that she's pressing or he's pressing? I bet you they'd love you to talk to them about it. Okay, that would probably break up the monotony of going backwards and forwards and backwards and forwards, you know. So it's just about encouraging parents to ask questions and be digitally curious as well. Okay, that's another, oh, actually, I didn't realise I'd animated this. There we go, look at that superb animation. Oh my goodness, warehouse. Oh, okay, here's another little simple one. And this is early scratch stuff. But we're starting from exploring right angles. So we'd often say to the children, where do you find right angles? Where are they? Take some photos of them, look round, discover them, do all of that sort of stuff, which is good for, you know, working out what right angles are. And then we'll get children, we put loads of shapes on the floor, and we'll get children to walk over the shapes, recording what they're doing, moving and turning and all the rest of it. Okay, and then we'll look at converting some of their algorithms that they've walked around into Scratch. Maybe we'll get on to, you know, introducing repeat loops if it needs that. Okay, so that's lots of fun. But actually what I like is the next bit, the last bit, which is where we look at some letters and we put big letters on the floor. And then what I do is I walk over those letters, like an F. F's great because it's, you know, and I really ham it up. I go over the lines 3 or 4 times. You know, I'm doing an F and I go forward and then I'm back a bit and then I'm left and then, you know, I do it in the least efficient way possible. Oh, I've done it in 16 moves. Right, I wonder if any of you can come up with a solution that has a load less moves in there. And they're all out there, you know, walking over. And actually, and then, you know, so that's a really nice way of getting them to think that sort of evaluative process for really young children. Okay, and getting that in there. There you go, that's some of them doing that right angle stuff. Okay, anybody see my jam sandwich stuff that's out there? Okay, so getting children to program their teacher to make a jam sandwich. All right, it's been lots of fun. Actually I have got it on there, I didn't realise that. We've got no sound. That's probably my fault because I did tell the guys I did have no sound on there. But let's leave it. Hey, anybody seen Beetle Blocks? Anybody seen Beetle Blocks? We love Beetle Blocks. So where we've done some of the sort of 2D programming, we've introduced the children to Z. That's been fun. Okay, and then got them after they've done some maths work on some of their shapes, actually got them to see if they can work out how they can program some of the nets. Okay, actually it's not nets, no, that's wrong. Anyway, some of those shapes. Okay, mustn't use the wrong maths language. I'll get told off, quite rightly. Okay, so that's been lots of fun as well. Here is some of the Scratch stuff we do. Okay, so this tends to be my sort of level 4 children. We tend to introduce some early Scratch at 3, which has our 7 to 8s. 8 to 9s, we get into much more of the repeat loops, a little bit of selection, okay, maybe a simple single variable for keeping a score, nothing too complex. What we often do is we get the children, we show them something like this, without the code and get them to decompose it. In fact, we did it with the parents at the Parents and Teacher Day, although that was a bit of a disaster with 200 parents in 2 different rooms doing it. Okay, yeah, okay. Actually, they loved it. I just wasn't massively happy, but that's just me, you know. So what was really nice, okay, is we get the children. So we ask the questions, what objects do you need to make, and what do you need to make those objects do? And in ordinary, everyday language, I need to make the slug move. I need to make it follow the mouse. I need to make it make that weird noise when it touches the outside. Once you've decomposed all that, you've broken it all up. So then you can either quite independently go and discover some of those bits, if the children are up to that, or you can teach them through some of that. Okay, or do a mixture of both, which is even better, you know, depending on what your class needs. So that sort of decomposition works really, really well. Okay. Here's something I love doing. I would say it's quite interesting. All 3 of the major curriculums in the UK for our K-6 all have a quiz program. So that tends to tell you that actually if everybody's sort of decided to do it, it's probably not a bad one to do. Hey, I did it first, but let's not go there, okay? So the Barefoot scheme, which is a good scheme as well, my Code It stuff has stuff, Rising Stars, which is a paid for, they all have the same thing. But actually we don't start with the quiz. We start with the human doing a quiz. And we get the children to think through the steps. We do loads of stuff about what happens and how it works. And we did that with the teachers from Roosevelt Island this week. So we start with that, then we convert that into a quiz. Okay, we do all sorts of other bits and pieces. Anybody seen Tickle? The Tickle app? We have quite a lot of schools in the UK have sort of almost got rid of laptops. They've gone all Mac, not Mac, they've gone all iPad. Now, I don't recommend that. I don't think it's a good thing. I think it's nice to have a mixed economy of stuff. But Tickle's a really good iPad app if you have got a school that hasn't got anything else that does some pretty decent coding. Okay, so that's the Tickle. The playground games. And actually it was Diane, my playground games, that actually notified Diane to what we were doing. So this is saying to children, we realise that flowcharts are quite useful things for younger children in coding. But, you know, when I crashed and burned so much trying to make them draw stuff in the early stage, it really was disastrous, okay, and boring. Okay, and what I realised, it's actually children couldn't sort of interpret a flowchart if they couldn't read one first. So what we did is we started with some playground games. So we just sent the children outside and said, look, you know, I'm not going to tell you anything about flowcharts, but here's a flowchart of a playground game. Go and see if you can work it out in the 2s and 3s you're working in, and then if you worked out, you can play it for a few minutes. That often gets them. Okay, so they go and puzzle that out quite quickly, and then we bring them back into class, take all those good versions off them, and give them a bugged version, which we turn on a line. That's quite fun, you know. But of course, they've had the experience of reading it in the first place. They've had to puzzle it out. So, you know, they don't always work out all of them, which is great. I don't want them to work it all. If there's nothing still left to do, what's the point of being there? Okay. So that's playground games. This is a module I really like. This is a Scratch module that I tend to do with my Year 5 children as an introduction. I remember talking to Professor Les Carr up at Southampton University. I said, if there was one programming thing that you'd sort of want every kid to do, what would it be? And I remember us having a big discussion about it. And he said, actually, it's the whole idea of changing a variable inside a loop. He said that that's such an adaptable thing and it just gets used so many times at that sort of early level. And okay. So we spent ages trying to come up with something. And all the things we came up with either way too complicated or, you know, didn't really fit. But this counting machine was a really nice one. Okay. So what we often do is we start the children by saying, right, on you go on Scratch, can you make the cat count? And they come up with loads of things like say 1, say 2, say 3, say 4, say 5, you know, and that's cool. Or they come up with, they go and record it as a sound file. And then I say, okay, I love all your ideas, this is great. I have to say, we are starting to see children who are starting, because we've hit a little bit of variable use, we are starting to see a few kids who start playing with the variables at that point, which is great, because they've actually made those sort of links that there's a possibility. We've not done anything around that. What's nice then is I say, okay, could you make it count to 1,000 then? Off you go. And they all go, go. Because of course, you know, that was the whole thing computers were made to stop, wasn't it? Repetitive, boring stuff. You know, so okay. And then what we do is we model it with some pens and pencils and a pot. We get a child to do that, and that's loads of fun. Okay, we give them a hint. That gives them a whole set of hints about a possible way to do it. Some of them will puzzle it from that. We've got a flow chart for those kids who don't get it at that point, but maybe got some part of it. Okay, and then we end up making a counting machine. Okay, I love Tickle because it actually shows you what blocks are on as well, which I think is quite powerful for children to see that. I think Scratch 3 is going to have that as a feature, and I think that's going to be a real improvement for visualising what's going on inside it. So what's nice is we do that, but we don't stop there. Then we say, right, okay, here's some extension. Can you make it count in twos? Oh, okay. Can you make it count backwards? Can you make it count in halves? Can you make it count in tenths or in hundredths? I have had kids running up to the front with their laptops. They shouldn't do that. I'm not saying they should, but, you know, for lots of safety reasons. Really excited. I made it count backwards. I made it count backwards, Mr. Bagge. Okay, so really good. And then we turn this into a countdown timer for our teacher. So, and we add in some input so you can say how long it takes. And then my favourite bit is the end of it. We say, okay, when you've done some of those other things, okay, we get to the end and you've made the countdown timer, go make it do something really exciting. Because no one wants a countdown timer that just stops. You know, and then I had a girl last year who made a countdown timer and the birds flapped her wings for every second, and then the bird flew away at the end. I like that. that was just so cool. Anyway, this is one we did with some of the teachers yesterday, so exploring some Cartesian coordinates. We have definitely found that this has made a massive difference. So we often have kids who've maybe done a week on maths and they've not actually understood how the Cartesian coordinate system works. The weird thing is, one lesson in Scratch, and we make them do it on paper first, because that's their algorithm. The only difference is we make them put the order of what they want to do in as well. Because, of course, there's no point just saying the coordinates. You've got to say, otherwise you end up drawing something quite different. Okay? What's really nice, and why the teachers often like it, is because, of course, when the thing draws it self-marks. What's cooler for a teacher than something that actually self-marks and you don't have to go and mark it? And then we do loads of stuff on that. We get into all 4 quadrants. We look at reflection in there because those are really easy things to do with that. Okay, here's a little example of some of the reflection. You show the children one of those and you go, well, what's different? Oh, Mr. Bagge, you put negatives in. I was in, oh. Right, go and see if you can make it reflect into the 3rd quadrant, the 2nd quadrant, 1st quadrant. Go on, off you go. And they're off investigating that. Loads of fun with that. This year, I actually did some stuff where we looked also at a lot higher level of stuff. So we ended up doing some reflection, some rotation, some enlargement. Not with all children, not all of them were mathematically up at that point. But, and actually, at the end of that class, the kids clapped the lesson. And I had stretched their brains further than I'd ever stretched them in lots of ways. But they were just so into it. And it was Scratch. I'd have never even attempted any of that stuff without that as a tool. Okay, so really, really exciting. This is something we do about how a network works. You guys, I know you have how the internet works. So we would understand an internet is a network of networks. So we would always start with a network, a local network first. Here's us drawing this network out on the playground and modelling it. So we get everybody playing this. This is a great one for getting teachers to understand it as well, because most teachers haven't got a clue. You know, and I say that in a nice way. So it's not their fault. It was, they probably signed up, and that certainly wasn't part of the deal when they signed up. Okay. What's quite nice is getting the children to draw a network model afterwards. Oh, actually, gone on one. I've lost a slide there. Oh, well, never mind. So there we go. This is a little project we did this year, which was around doing some physical computing. Now this is the Crumble controller. In the UK, those are £10. And you can plug in all sorts of things like motors and bulbs and distance sensors and PIR sensors and all sorts of stuff with it. So for our younger children, this one here was our year 4s, and we just used a little servo motor with that to make these animated animals. And we did it in 3 hours, so it was a doable project in a short period of time. Because what I tend to find is a lot of teachers, it's not that they don't like the design stuff, it's just that they don't have the time in the curriculum to get it all in. So if you make a much shorter project, then people do it. This one's a little bit more advanced because he's brought in the button there. So obviously there's some selection in there, okay, and they're having to develop that. We've made a version which has a PIR sensor. So and you can pop those on the wall, and when someone goes past, it deflects them, and the little head goes. All right, which is not that different from a lot of those horrible Christmas decoration things that dance and do all sorts of other stuff at you. Okay, so those are fun. Oh, that was the slide. Don't know how that got mixed up. That's what happens when you do the slides half an hour before you get here. So, okay. This year we did Robot Wars. That was the most fun, exciting thing. My son said to me, "Can I move schools and go and be at your school?" He's never been in. The last thing he'd ever want to do is go and work with me ever. You know, he's lovely, but there's no way I want to be with Dad. Why? Because of Robot Wars. So we made the children. We got them to design their own robots. They had to say what type of weapons they were going to put on. Now I had these visions of all sorts of stuff flying off and getting damaging. Actually, the 3-volt motors really don't do much damage at all. Okay, and I did have a few teachers in the UK said we don't like the idea of wars. So if you know, I'm cool with that. You could have done a robot competition. It's the same sort of idea. We made the children have a fixed course. How quickly could they get to A to B? Because they'd all built in little buttons using wires to steer the thing. So they had a button to control the motors. Okay, you can see the little bits of programming on the right hand side there. Okay, they could do an obstacle course with that as well. And then we had some battles as well at the end there, which was lots of fun. That's the little crumble controller that we use, and we can get that into school. Here's a quick vid of some of their, there we go, some of their very slow, the excitement for something that only moves at 2 miles an hour. It's just, you know, it's just amazing. Yeah, okay, I have taken the sound out of this because there was lots of chanting and shouting and all sorts of other stuff. But, yeah, anyway. So lots and lots of fun.
So they're not tethered?
They all are tethered, yes, they're all tethered. I'd love to have done wireless, but the thing is, with the tether, they could all do it themselves. It didn't need me to have to get involved and do anything complicated. And I'm a big one for, you know, if the kids can do it all themselves, then it's worth sort of doing that point. I'm not saying you can't, you know, cheat a little bit on occasions. That's really low tech, isn't it? But hey, you know. This one was fun, although it did absolutely no damage at all because they hadn't really worked out torque and tension and those sorts of stuff and gears. We'll get on to that. But yes, sir. Yeah. Well, now we love the BBC microbit, but for our younger children, it's not simple enough. Well, I'd say for secondary, 7, 8, 9 for us upwards, it's really good. It's more about what we found even with this is there's an abstraction that happens. So what I mean, if I go back to that previous slide, even the things of is B high? Well, what's B? Unlike Scratch, you can read everything, you know, this does this. But what is B? And what's high, Mr. Bagge? Okay, now don't get me wrong, kids can understand it, high and low being on and off. But of course, B could be plugged into, it could be an input, could be an output, you know, so there's a load more complexity of that sort of side. What we tended to find is that when you added all the kit to stuff, you almost had to lower the programming level a bit. Okay, and I think that's really important to say. So whereas kids might be really competent at using variables in Scratch, we'd almost take something like that out for a project that involved the kit. Because there's a complexity of plugging it in and have my wires touching and have I sorted something out and all of that sort of side of stuff. Which is, we love this though, because what the guy's done here is they've allowed you to do either crocodile clip connections, which is good for older kids, or you can plug in like a phono lead. You know, like the little headphone leads? So for our most younger pupils, we did make some night lights this year with just a box, punched holes, okay, and just a single programmable light. And my year 2 kids were able to choose the colours and make a nice sequence and decide how long they wanted it to go for. And that was perfectly okay for them. They could do that quite independently, but they could only really do it because they were plugging this in. The crocodile leads, they just slip off younger fingers. Nobody wants that. Okay, we've had a look at that. Here's a little coin sorting program. Okay, developing a bit more complexity, spending time looking at function machines and how they work. Okay, and what happens when we feed those sort of numbers in there and how we can break it into coins. Getting a really understanding of what's going on with the program before you actually do anything actually in the program. And then converting that into a change-giving machine. Okay, introducing some lists. We tend to do some simpler things with lists first. So things like we often do like a very simple fortune-telling program where you just put lots and lots of jobs and then you say so-and-so randomly choose from job list, which the kids thoroughly enjoy. I have to say one of my worst mistakes was getting an older class and letting them make a random romance generator. Now don't get me wrong.
Sorry, did you say romance?
Yeah, romance generator. Now, I know, cover your hands. That was a bad idea. Okay, and as a professional seasoned teacher of many years, I should have realised that. But I'm being honest with you. Don't get me wrong. They've never done so much programming. Okay, but you know, it wasn't good for lots of other reasons, and I wouldn't do that again. But hey, I bet loads of them went home and did it at home. But planning and building a clock was a lot of fun. So we start looking at things like digital clocks. Okay, and what happens when the clock goes across from the seconds into the minutes, and then we're not going to make for the minutes to the hours, but you can surmise that, writing lists, thinking about what happens, and then looking at that in a pattern in a flow chart and getting children to predict and work out what the pattern is, what happens with the seconds, what happens with the minutes, what's going to happen with the hours. Okay, matching some of that to some of the scratch blocks and then actually building a clock. Okay, I followed some children out of school, well that sounds a bit weird, on the way to somewhere else to train some more people, I want to say that now. And one of the kids turned to me and goes, I don't believe we actually programmed a clock today. Oh. And I thought, wow, you know, when kids sort of, what I love is all the other stuff they do with this as well. So we end up going and turning it and getting them to program their hands as well. So we get into some maths and breaking up 60 into different sections. We had some kids who made a Doctor Who clock this year. Okay, went backwards. Not the most useful clock, but loads of fun. All right. So a real wide range of programming. Here's a project we did last year, which is Paralympics. So we got the children to look at all the Paralympic sports and how technology could help Paralympians. And I have actually seen some of my senior colleagues in year 7, 8 adapt this type of idea. So what they looked at is coming up with a big idea. So it's to help blind people do long jump by creating a sound to tell them when to jump, using a distance sensor. So they design that, make them actually draw out some of the programming and the wiring because it's quite complex. Okay, much better to work it out there than work it out on the thing, and then actually go and build those things. The only thing, I really loved that project, but we didn't build any good design around it. We didn't build something to hold it in, and I think that was a failure on my thinking really. I was thinking programming and bits of kit, and actually they needed to build something that actually fit, you know, that would have been better. But hey, we'll learn from that. Okay. Sorry?
Debugging.
Yes, yeah. Teachers have to debug as well. So those are some of the projects we do. I've only hit on a very small selection of stuff. I didn't want to go on for too long. But it has been the most enjoyable and challenging time. And one of the biggest things we've really sort of tried to do is sort of take teachers with us bit by bit, you know, and to do little incremental bits of training, share new projects on a sort of
and get teachers to actually build this stuff themselves first, try stuff out. And our elementary teachers have really risen to that. They've enjoyed that sort of side of things and learning new stuff. A lot of them were very negative in the first place. Don't want to do this stuff. But actually, when we sort of talked about the sort of thinking skills involved and took them through little by little, go do a couple of really simple projects, like we did a conversation, which is, really simple sequence. Go do that with your class before we come and teach you something else. And then come back and tell us how you got on and what worked and what didn't work. And now let's take you a little bit further and do something like the quiz. Let's go do that with your class as well. Okay, and little by little, what we're starting to see is, because we sort of involved them in the process, and they're starting to adapt stuff as well, which is really, really nice. And some of them starting building their own stuff as well from scratch, I want to say, but you know what I'm saying. Okay, we're not sorted in the UK. We haven't got everything right with this process, but it has been a lot of fun and very creative as well. But if there was one thing I would encourage you, it would probably be to go back to that slide with all the problem solving stuff. Because for me, that has been my sort of guide since I got into that. That's sort of just transformed what I think about all of this. Okay, and I didn't get there straight away. As I shared last Friday, loads of missteps as well as good steps. Anybody got any questions? Sorry?
Here, give me the mic and I'll pass it around.
Yeah, sure.
This one.
Okay.
I know what my job is here. Okay.
Anybody got any questions?
There you go. Thank you.
With each of your classes at different age levels, how often do you meet and for how long?
Yeah, okay.
Of a stretch?
The programming element, the computing science element, is only one part of computing for us. So we would still include meaningfully using technology, spreadsheets and databases and all anything else you're going to do as part of that. So typically schools do probably about a third computing science. So we're probably talking about 12 hours a year on the computing science stuff. Now some do more and some do less, but that's typically. There's in our schools, the head teacher, our principal, is a bit like God in some ways. So it depends to some extent of what they're sort of allowing or what their sort of theme is for the school. So some do a more minimal and some do a lot more, depending on whether I've been in there and worked with them.
So is it like we're going to do 12 hours over the course of a month, or is it spread out throughout the whole year?
Teachers do it very differently. So some teachers, I tend to encourage teachers to block some of the programming together, because I actually find that if you're doing a bit, then you learn from that, and then you tweak it a bit more and you learn. But the teachers do break it all up as well. The big thing for us is saying to teachers, actually, do make sure that if you've had some training, that you go and use it really quickly. And we also talk to head teachers or principals about just doing a bit of light checking to see whether it's happening. So what we say to principals in the early stage, we say, don't go and do formal assessments on this stuff, because people are learning. And if you do it really formally assess it, then you'll probably, you'll either clamp them down to doing very sort of rigid stuff, or they'll, So what we tend to say is go and have a bit of a peer chat with the kids about what's happening. But you tell everybody, look, I'm gonna talk to a few students from every class about the computing science they're doing. That just means that's low pressure. But it means that people have got to have done something, so that their students say they're doing some stuff, or have a little bit of work moderation, or looking at what's happening. And what we say to principals is, don't expect genius in the first couple of years. It's going to take time, and it's really important. I think the biggest pressure on teachers is not being allowed time to learn themselves. And if they're not allowed time to learn, then they often just buy out of the process, or go for stuff which is not so open-ended, stuff that sort of constricts them a bit more. Does that help? Mm-hmm. Thank you. Any other questions?
Hi. Have you gotten to hear any feedback or collected any data from other teachers that you haven't actually worked directly with about the attitudes of resilience showing up in the kids elsewhere outside of your interactions with them?
I have to say no. Interestingly, Southampton University wanted to do a study on that this year, and to try and find some schools that we're just getting into and some not. But we haven't managed to tie that up yet because I keep being away places. It's my fault. But I think that is definitely something we should do, because I have lots of anecdotal evidence about this, but I think it would be quite a powerful thing. I'm also really interested in how much I think that's probably what you were talking about, how much it transfers into other classes. Interestingly, when we asked children this, I've done interviews with a few classes, and they've said things like, well, in computing, I try and puzzle it out, but in maths, I just put my hand up. So that's interesting. So I'm not always seeing the crossover, although I have had children on the opposite side say things like, I'm debugging my sentences. So that's powerful. And now I know that's a wrong understanding of debugging. Debugging is about code. But for really younger pupils, I'm telling teachers, leave it alone. When they're a bit older, people have changed the language. If they get the idea they've got to fix the sentence themselves, that's great. I don't ever want to stop that. And if they like that word enough, that's a good word for them, then that's cool. So, yeah. But yeah, we should do some more research around that, definitely.
Also, just because we're on this slide, is the picture for Persevere supposed to be raining blood? Or is that something else?
Yeah.
But is it red? Oh, it's not red on there. It looks red over here for some reason.
It's sort of purpley, but yes, it was that sort of sweat.
Okay.
That was my original idea, but don't get me wrong, guys. If you like different symbols and you don't like mine, use your own. I won't. I'm cool. Well, hopefully, we're not making children sweat blood. Not quite that level. I mean, I like some perseverance there, but yeah. Anyone else got a question? Sir.
I was wondering whether their website, code.co.uk, is similar to code.org that we use here.
No, it's just my website.
Oh, your website.
It's just got hundreds of teacher resources on there. I won't have put them all into a scheme for you. I do have a book, How to Teach Primary Programming Using Scratch. But actually, I really like it when I go and work with teachers, we work through progression of programming, and we often sort of talk about using things from different sources, not just my stuff, but some stuff from Barefoot and other places, and dipping into things. Because I think it's quite nice to if you build a curriculum yourself, you sort of own it a bit more. Even if it uses other people's things. And we're big ones. One of the things we're finding is really good is getting teachers to collectively do some formative assessment around stuff. So what were the sticky points in that lesson? What was the learning? How do I know those children were learning? What were the corrective activities I needed to do to move pupils on? Or what was the enhancements type stuff? And that group working on a project, maybe that they've all done something like the quiz, and I did this, when they got stuck with that, I did that. Oh, no, okay, that's good, I love that. And that builds ownership as well. So that sort of formative assessment
I
stuff.
could not check their website on my phone because there's no Wi-Fi connection here.
Okay, it's got no WWs to it, it's just code-it.co.uk.
And I don't have to use a username and password?
No, it's all totally open.
Okay.
I don't restrict anything, and I don't charge for anything. It's lovely to be able to share.
Thank you.
Sir, sorry, and then this lady.
Sorry, I was looking through your National Computer Studies curriculum.
Yes.
And I was particularly interested in for the older age groups,
Yes.
subjects that go beyond what you've spoken about
Yeah,
today.
sure.
Algorithms, search, responsible use of technology and so forth. That seems to be quite way ahead of the United States anyway in certain areas. Can you tell me, are you familiar with these areas?
Yeah.
And what material do you use in schools for teaching the older, so 9 through 12 or 6 through 12?
Yeah, sure.
Thank
And
you.
I just want to say one thing. I think you've probably got a strand of data that I don't think we tap into quite so well. So I think you've probably learnt from some of our stuff and moved on a bit. So I'll put that out as a balancing thing, because I like our curriculum. But So typically in what we would call Key Stage 3, which is our 7, 8 and 9, we see a lot of teachers doing some advanced scratch early on. So really taking on. Often they're having to cope with some schools that have done loads and some schools that have done a little. So there's that sort of trying to catch everybody up to a reasonable level. We see a lot of Python. So Python 3 whatever it's up to, it is the most used language in schools. I wouldn't say, I mean, there are disadvantages for that, you know, but it's not a bad language in terms of sort of being able to read bits of it. So we see a lot of that. I've done some Python programming with my year 5s and 6s. And actually, but I don't make a big thing of that to elementary teachers because, is that the right word? Because I actually think it's not that they can't do it, it's just that there isn't the time to develop the skills in it as a teacher, you know, with all the other stuff. Whereas I actually think you can develop some pretty good scratch stuff given a bit of time, you know, and a bit of training. Whereas actually, you know, that sort of, the microbit is used. So often with our year 7 and 8 students, the microbit is a really nice physical. And in fact, you were doing some great stuff today with the microbit over in, what's the name of your school? Yeah, so that's a love. Children love that physicality of seeing stuff move and turn and light up and all the rest of it. And there's definitely, even the block-based Blockly that the microbit uses is more complex than Scratch. I think often people look at things and think that that's the same complexity, but just the having extra bits that plug in and do stuff adds complexity. And there's definitely more complexity with Blockly and Scratch. And then there's MicroPython if you want to use that. So if a teacher's teaching Python, MicroPython on the microbit is a really nice way in. But there's a real, you know, no one's saying there's a whole, for the exams, there's quite a lot, there's other languages which are acceptable. So some people will be using other things, more web-based languages as well, to develop stuff. So there's not a hard and fast, although I think a lot of teachers will be thinking, because we have an exam in computing that children would elect to take at the time of their first set of exams. So a lot of middle and senior school teachers that would be starting to think about, well, you know, how can I get them through that as well? The downside of having an exam, though, is what we've seen is it's how do you assess programming? So what we've seen is the programming element go from quite a big element to being narrowed and narrowed and narrowed, mainly because the examiners can't cope with it. And I think that's quite sad, really, because it's often one of the most sort of creative and it's often the bit which often gets the kids interested. I'm not saying it's, you know, they do need the theory and the understanding and the hardware and all the other stuff. They really do need all of that as well. But I think that's the downside of having a very fixed exam at the end. Was this lady here? Thank you.
So you do a lot of teacher training with teachers who are working in schools.
Yes.
What about the institutions that train young teachers to go out into classrooms? Has this kind of education been instituted in those places as their pre-service teachers?
Yeah, I mean, that's really interesting. So we did some work very early on with a whole host of teacher training organisations. Mm-hmm. And it was sort of useful, and it was sort of not. I think it's been interesting. Quite a lot of them get people like myself and some of the master teachers who are teachers come and do some of that, but it doesn't tend to be more than about a day, which I wouldn't really say was enough. So you're relying much more on what the school have done and what sort of training they've got in to be useful. Do
you see that changing?
Yeah, I do. I think actually thinking about sort of common standards and examples of things for teachers I think there's some good work we can do with that to develop it. So yeah, I do think that can change. Yeah, definitely. Got some lovely people who are really interested, and they do recognise what this does for children's thinking. So there was a real negative thing with this at first. Oh, why are we teaching them to program? And then when we've sort of framed it around thinking and attitudes, then a lot of the teaching communities come on board. So that's been really nice. There has been a sort of a general shift in thinking. Did you? Yeah.
I was just seeing like how you change the questions, right? So, for example, you ask them to look at like at the path, and then you say, well, how many paths are there? Enumeration, right?
Yeah.
And you say, well, what is the best path? You
Yes.
know, so you're going from like polynomial to like non-deterministic kind of like problem solving.
Yeah.
And what we have like right now is the children need to understand that there's going to be certain things that machines are very good at. You know, and they're gonna take over, and you're gonna have to do the things that humans are, you know, much better at judging, and maybe the machines are also gonna get better at that. But just being able to recognize the problems and going from simple to complex and using it in an open-ended way, that was very nice. I like that.
Yeah, no, thank you. It's changed how I've taught, and that's
Yeah.
and I like that. I like anything that actually affects my own practice as well, because I don't think I think we've made massive strides. I love what I'm doing, but I think there's still some more to learn, and I love that. It's get me excited. Thank you.
You mentioned assessment. I'm wondering if you do formal assessment with younger kids, and if you do, how, in what format?
Okay, we don't have much formal assessment. What we recognise with K to 6 is that often the best assessment is to develop some good formative assessment and use that formative assessment in a summative way. So it might be thinking about, well, say we did an example like, what's that one? Here we go, this one. So say we told the children, can you go and find as many different ways to make a coloured line out there? And that's quite nice because there are about 4 different ways. And so just recording how many they'd come up with is a nice little instant sort of formative assessment that you can do in the lesson, which gives me some indication of where you're at. So we're often looking for that low-hanging fruit. And we're also looking at, you know, some of the projects and certain points in the project of what children have done as well. That's the programming. And because we do a lot of the thinking beforehand, we can assess some of that stuff. So if we got children to decompose and write some of that, we'd be assessing sort of the quality of what they've done in that as well. There are moves to do much better assessment. Well, I say better. Personally, I'm a big believer that actually that sort of formative stuff actually produces some of the best summative. But what I'm really against is I'm going to impose on you a summative test that doesn't really fit your curriculum. And I hate that, I just don't think that. So I'm cool with people designing summative stuff, but it's got to be teacher-led and it's got to actually be reflective of your curriculum. Otherwise, really all you're doing is assessing somebody else's thing. But yeah, thank you.
I have a question for you about, you had shown a slide with the sensors, and I have 2 questions actually.
Yeah, sure.
The first one is, as we all know as educators, sometime in the classroom environment, the learning do take place, but sometimes we have to take education beyond the classroom. My question is, these activities, are you also looking at kids going home and continuing what they're learning in school?
Yeah, no, in fact, actually, I'm glad you raised that. In my book, what I did was did extra activities sheets.
Okay.
And so when children ask for that stuff or they're interested, we can give them another sort of, and that's just a few extra steps. We have like a 1, 2, 3 star thing. So here's a simple challenge you could do, which is often go and build the stuff, a version of your own at home. And then the next challenge might be a little bit more of an open-ended one, so they can decide. And I have to say, if I had £1 for every kid who's come, oh, Mr. Bagge, I made that, nice. I'd be really rich.
And the next thing is, I know since 2012, the Raspberry Pi practically take over the world.
Yeah.
Just a general question, how is that really in England, the Raspberry Pi?
Yeah. No, thanks for mentioning that. We did dabble with using this in sort of year 5 and 6. We just found that it was often in elementary there was too much setup to it, and that was a sort of issue. But it's some educators in the sort of 7, 8, 9 use it massively. And if they like it, they tend to do Python on it. They tend to do all sorts of stuff on it. There's a lovely, what's the Sonic Pi, which is a music programming. So, you know, they use it for quite a lot of stuff. You tend to find educators either buy into it and use it for loads, or they don't use it at all. In the UK anyway.
Gotcha.
And there's a whole Raspberry Pi Foundation.
Right.
Yeah, I should have mentioned the Raspberry Pi when I mentioned the microbit before. So thanks for bringing that up.
Sure, no problem.
Appreciate it. Any other questions? Well, thank you very much for listening. Thank you.